video, I am going to talk about conservation of linear momentum and Newton's practical law. So first I am going to talk about conservation of linear momentum. Simply, I can say that conservation of linear momentum means the total linear momentum of a system in some considered direction is constant at every time. To explain the conservation of linear momentum, I consider collision of two spheres. This is the sphere which has mass ma. This is the sphere which has mass mb. So they come in towards each other with velocities va and vb. After the collision, they repel from each other from velocities v1 and v2. So for this situation, I can apply conservation of linear momentum. For apply the conservation linear momentum, first I have to select direction. So first, for this problem, I'm going to consider the direction as this. So all the vector properties to the right arrow direction is positive and the opposite vector properties are negative. So I can write. So the simply I can say the initial linear momentum equals final linear momentum. Right. So the initial linear momentum of the system I can write considering the direction. I'm first going to write the linear momentum of ma. So we know that the linear momentum we can get product of mass and the velocity. Then the velocity of the a sphere is same as our direction, so it is a positive velocity ma into va. Linear momentum of b sphere is mb vb, but the velocity of b is opposite considering direction, so it is a negative momentum. Then when we consider in the final velocity of a sphere, it is ma v1, and the v1 is the opposite direction to the our considered direction, so it is a negative one. Since v2 is in same direction, I can write mb v2. So simply this is the conservation of linear momentum. So by applying conservation linear momentum, we can get values for the masses, velocities, and sometimes constant in the problems. They are given in the problem. So simply I can call this is as the conservation of linear momentum. To apply the conservation of linear momentum, there shouldn't be external forces acting on these objects. If there is external forces acting on these objects, we cannot apply conservation of linear momentum, because the external force can be done somewhere. We cannot calculate it using this. So there must not be external forces. Next, I am going to talk about Newton's practical law. This law is also talk about collisions between objects. So I take same example, sphere collision of A and B. So in here, Newton introduced new constant which called restitution coefficient of restitution between two objects, right? So when we consider Newton's practical law, so we can Newton says that the difference between final velocity to the difference between initial velocity is a constant. That's a Newton's practical law. So when we apply this practical law, we have to consider direction as above we use in conservation of linear geometry. It shouldn't be the same as this. We can consider any direction, right? So in this part, I am considering the same direction as above. So Newton says that the difference between final velocity. So difference between final velocities. So I'm going to get difference v2 minus vb. So velocity of v minus velocity of a. So I can write it as v2 in the same direction I am considering. This negative mark comes from the Newton's practical law. So then I have to negative v1, but v1 in the opposite direction we consider. So the v1 is a negative value minus v1. So the difference between final velocity to the difference between initial velocity. So the initial velocity of b is vbn. It is in the opposite directions that we consider. So it is a negative vb. And this negative mark comes from equation. And the initial velocity of a is va, which is in the same direction as we consider. So if we get the difference vb, velocity of b minus velocity of a of final velocities, we have to take the initial velocity is also the vb minus va. We cannot change. If we get the difference va minus vb, be wrong. If we consider the first velocity of b, then the final velocity of vb must consider first. So it means I cannot write v2 minus v1 and va minus v minus vb. I cannot write this equation as this because v2 is velocity of v and va is a velocity of a. It cannot be happen. So v2 is a velocity of v, then vb also the velocity of v. v1 is a velocity of a, va also be the velocity of a. Right? We cannot apply this equation right this. So then this constant value is a negative e. The e is the coefficient of restitution. Coefficient of restitution. Right? So the value of e is between 0 and plus 1. So it can be 0 or plus 1. The maximum value of e is 1. The minimum value of e is 0. And e lies between these two values. So applying this law, we can get the relationship between velocities and find the given unknown velocity. So this is conservation linear momentums and Newton's practical law is used in normally in simple harmonic motion, circular motion problem. That's we learn about this. We can use them in problems in applied paper. So these are very necessary things. You have to simply understand it. And there is another thing. This is we talk about the collision of two spheres. But if something happens like this, the sphere is going to collide with a wall, right? The sphere comes constant velocity v and collide with wall where the coefficient of restitution is e. Then the sphere is repelled from the velocity ev. If we collide with v velocity, it's repelled with velocity ev. Right? Simply remember that. it doesn't not going to be the ball, it must be a stationary thing, right? If it is a stationary thing that collide with the sphere or something with velocity v, then it's going to repel with ev velocity. It is also a necessary point to solve problems. So today topics I have discussed simply, right? This is not deeply. This is simply explain what is the conservation of linear momentum and the Newton's practical law. We're going to use this in another videos I am going to do. So in next video, I'm hope to discuss the circular motion, and we will see in that video. Thank you.